Melting points also involve heat, energy. So they will follow the same boiling point trends. In terms of the different forces, that means, hydrogen bonding is the strongest, followed by dipole-dipole. And then, of course, the weakest would be the van der Waals. So again, this would be the highest melting point, and this would be the lowest if they have comparable molar masses, same number of atoms. So if you have, so that applies. However, when it comes to alkanes, we have to be careful because we need to look for this word right here. We need to look for symmetry, symmetry, symmetry. And it goes like this. The more symmetry the molecule has, the alkane has, the higher the boiling point will be if they have the same number of carbon and hydrogen atoms. So let's look at this example. Same number of carbons in each of these. You can count them. 5 carbons, 5 and 5. If we look at the melting points of these, this would be negative 130 degrees Celsius. Very, very low. This one would be negative 160 degrees Celsius. But this one, the last one, the one with the branching, is negative 17. Look how high this is. Incredibly, incredibly high compared to, let's say, the first one or the second one. And the reason why is because it has more symmetry. So in this case, this is more symmetrical. Which results in a higher melting point. So the trend goes like this. I'm going to write it down underneath here, is that symmetrical molecules pack better in a crystal structure. So this is why branching and symmetry helps. Melting points is when you go from a solid to a liquid. And in a solid phase, the molecules are packed into a smaller, very, very smaller volume compared to liquids and gases. So there has to be symmetry in order for them to pack better. That's the explanation here with the melting point. So again, symmetry, look for symmetry. The more symmetry it has, the higher the melting point will be, because again, you need more energy to overcome that.